Good afternoon, everybody. Good afternoon to this final session of the final day of the EUCAD conference. And oh boy, it has been a fantastic conference up to now. As they say, we have saved the best for last for yourself. We are going to have a super interesting discussion right now. The breakout session number 12, the last one. We are going to be discussing how can CCAM contribute to the all environmental goals and targets that we have ahead of us. My name is Zeljko Jeftic, and I'm going to be the moderator for this session. I have 4 fantastic speakers, and I'm just excited to be with you here today. I would just like to, before we start with the presenters, I would just like to share a couple of slides, if you can, please, with you, just to show you a little bit of background for this session. So while we are setting up the slides, I am just going to tell you a little bit that we are experiencing basically the 3 historic days right now. Probably 3 days that are going to go into history books. But before I reveal that, I'm just wondering if the presentation can be seen by everybody, because I cannot see it yet from my side. Just a second. Okay. I have a little bit problems to see the presentation. Okay, there we go. Now I can see it. Fantastic. I'm an engineer by the background, as you can notice, on a Thursday afternoon. So if you go to the next slide, please, I would just like to mention a couple of things. So we all know that European Green Deal is a major policy objective for the European Union, the European Commission, that has been now set out in end of 2019. There's been much discussion since then, and we are going to hear much about it still. And what is really interesting is that yesterday we heard also that European Union adopted a new climate law, which means that we need to reduce CO2 emission at least by 55% by 2030. This is compared to 1990. Insanely ambitious. Now, if you were the only one in the world doing that, that would be challenging already. But UK, 2 days ago, announced that they are going for 78% reduction of greenhouse gas emissions by 2035. And just a couple of hours ago, our colleagues from the US and the Biden administration announced their major challenge, and that is that by 2030, they aim to reduce the greenhouse gas emissions by 50 to 52% compared to 2005 levels. So in 3 days, we have had the UK, EU, and the US setting, I would say, historic targets. We all know that setting historic targets is not something new. We have heard about this before, but it seems that this time we are really serious about actually achieving them. And if you look at the European Green Deal, because we are focusing primarily on European audience in this Congress, we can also see that when we are looking at the transport, there's an element of automation. And personally, having worked on automation and ADAS and everything in the vehicle technologies since 2006, I was personally surprised to see that automation was one of the pillars that European Commission was counting on to support when it comes to environmental protection and decarbonization. CCAM and automation and connectivity has huge potential for benefits when it comes to road safety. Absolutely, it has a great potential to create jobs, etc., etc. But it is a little bit more unknown how can automation support directly the decarbonization. And this is also why I'm so excited to learn from the speakers that we have with us today. If you go to the next slide, please. Now, from ERTICO side and from our partnership side, we have also started already at the end of 2019 and run it through 2020 as well. We have started a so-called city moonshot, where we are working on interviewing 300 cities in different parts of the world on 3 topics. The first topic is, and I think most relevant for this audience here as well, is sustainability. We are interviewing cities on air pollution and climate change to see how the cities are thinking, where they are heading. We are interviewing them on data sharing, and we are also interviewing them when it comes to mobility as a service and mobility on demand. So this is a map here that you can also see of the cities that have already been interviewed in Europe. Overall, we are at approximately 120 cities that have been interviewed up to today. I believe we have interviewed with Nanjing today and with Yekaterinburg in Russia. And we are continuing on this pace. I would just like to share a couple of results with you, and that is, if you go to the next slide, please. That is that if you look at the cities and how they are thinking about climate, we see on the right map already that there's a large amount of cities that have announced a climate emergency. From our own survey, we also see that 44% of the cities, and this is preliminary results from first data, 44% of the cities have already or are aiming to announce climate emergency. And it's really interesting to then discuss with the cities, okay, great, but what does that mean from a transport point of view? What are you going to do about it? And how will that impact transport and mobility? So we have a couple of examples on the next slide that I can show you. Here we, for example, see that according to first results, preliminary results still, which are biased still because we have started with the biggest cities, let's say, and we are still rolling out our interviews with more smaller cities, so to say. But we see that electrification of vehicle fleets is one of the top priorities. So here we need to then discuss how can cities, together with public operators, with vehicle manufacturers, and everybody else who needs to be involved, how can we support more infrastructure, electrical vehicle infrastructure implementations in the different parts of Europe? Bicycle lanes are also another hot topic amongst many cities. Public transport and, of course, transport policies and updated plans are also very much on the top of the agenda. If you go to the next slide, please. We are also asking cities at the end of the survey, even though we are not going into depth with many questions on this, we're also asking them from these 58 questions, are you as a city representative interested in learning more about vehicle automation and how that will impact and how that potentially will work in your city? And it is absolutely resounding 85% of the city representatives that are stating that they're absolutely interested in learning in vehicle automation. So this is really interesting results that I think are relevant for our discussion today. I don't want to take too much time from my side, but I just felt that this is interesting for you to learn. We are reaching out to cities. Cities are some of the biggest climate change drivers against climate change, so to say. And I'm also very much pleased that we also have one of the cities with us today. Now, from the 4 speakers that we have with us in this session, we are going to hear from Professor Coelho, who really has extensive background into looking into connectivity and automation and its impact on the environment. And to be totally honest, I've been working in this field, as mentioned, since 2006, or actually it was even earlier than that. And when speaking with a number of my colleagues and a number of experts in the field, it was difficult to find people who would actually say, well, I'm working in the field of automation and connectivity, and I see myself as an environmental expert, so to say. It was really difficult because we have not been touching this topic so much. The second speaker is going to be Jos van Vlerken from the city of Copenhagen, who is also going to give us a perspective on how a city sees automation. The third speaker is going to be Pierre from NAVYA. I'm sure you all know NAVYA very well right now. Self-driving shuttles, focusing a little bit more on the passenger transport. And as a cream on the cake, we also have the final speaker who is going to give us view a little bit of what is happening in the US, how thinking is in the US, and potentially also a little bit internationally, which is Richard Bishop, a well-known expert on especially truck automation in the US, but also worldwide. So that said, I don't want to take much more of the time from these fantastic speakers. I would like to invite Professor Coelho to give us her insights into this interesting topic.
So hello and a warm welcome from the sunny Portugal to all my panel colleagues, and thank you, Mr. Moderator, the Zeljko, and also to the audience, a big welcome. And thank you very much for the invitation. I see that I have here my slides, and my presentation is entitled Emission Impacts of CCAM from the Use to a Life Cycle Approach. Next slide, please. So before getting into my presentation, let me just say where the University of Aveiro is. It's in Portugal, in the central region of Portugal, and we develop research on mobility on mainly 4 topics: impacts of mobility, namely emissions and road safety, also cooperative connected and automated mobility, LCA lifecycle assessment for transport, and also active modes. And our main motivation is to contribute with our research for less energy intensive, clean, safe, and sustainable transport systems. Next slide, please. And I made my PhD in the Technical University of Lisbon, and my field of expertise is transport, energy, and environment. And in University of Aveiro, I teach at the Department of Mechanical Engineering, where I also serve as the course director of the master degree on the smart mobility and vice director on the Research Center for Mechanical Technology and Automation. Next slide, please. So my presentation will have these 4 sections. I will make a brief motivation that Zeljko actually already made a bit. Then I'll present in a very simple way and direct way the methodology and methods that we use to quantify emission impacts for automation. Then I will present some of the results of our research, and I will finish with some take-home message. Next slide, please. So we all know that transport is a very important sector for European businesses, also for the global supply chains. But we are aware about the impact. So 31% of energy consumption is dedicated to the transport sector. If we look only to the greenhouse gas emissions of transport sector, 72% are related with road transport. We are concerned not only with CO2 emissions, but also with other kinds of pollutants, such as NOx and particulate matter. And we all know about these transformational technologies and services for mobility. I used to say to my students, it's the best times to work on mobility aspects, because there are automation and other aspects for technology. But in terms of environmental and sustainability implications, as Zeljko was saying, none or a little piece of research is being done. So we would like, and this is the main motivation for our research, to understand and quantify the emission impacts of automation. Next slide. So for that, we use an integrated approach. We use traffic and fuel consumption emission models integrated. So, for example, we need to reconstruct the vehicle trajectory, not only conventional vehicles, but also automated vehicles. And we link with an emissions methodology called vehicle-specific power. And if you put on the next slide, please. We need to calibrate this vehicle-specific power methodology that is a very microscopic approach with a portable emission monitoring system results. So we do some experimental campaigns with this PEMS equipment in order to measure second by second emissions, CO2, NOx, particulate matter. So on your right, you can see a graphic with raw data. Besides the vehicle dynamics, we can assess second by second CO2, NOx, particulate matter, and then we can aggregate these raw data into modes. So for example, these vehicle-specific power modes, number 1 and 2 are related with the deceleration modes of the vehicle. If we go up until VSP modes 10 to 14, these are related with periods in which the vehicle is at the high speed and very high acceleration. So we can correlate the vehicle dynamics with emissions. If you go to the next slide. So now I will start to briefly present some of the results of our research, namely some papers on the emission impacts of automation, and this work specifically explored the environmental impact of automated vehicles along a metropolitan road network, which included a freeway corridor in a metropolitan area. And we we implemented scenarios with different automated vehicle penetration rates in this corridor using 10, 20, 30% of automated vehicles. Then we calculated CO2, NOx, and other pollutants. And mainly the concern here is that, okay, we will not have a turnout from 0% to 100% of automated vehicles. So meanwhile, we'll have the challenge of coexistence between automated vehicles and conventional vehicles. So what we found out is that the challenge relies on that coexistence. Automated vehicles yielded some small savings in terms of emissions when we have automation levels below 30%. And if we have, for example, CO2 emissions per unit distance, it's slightly decreased for these low penetration rates, and they can actually increase these emissions if we have automated vehicle penetration rates around 30%. Why? Because the conventional vehicles have to coexist and adapt their driving to the existence of automated vehicles. So I might refer that here in this work, we considered that the automation vehicles are gasoline or diesel, and I will further present some results with electric automated vehicles. So next slide, please. So here, besides the challenge of coexistence between automated vehicles and automated vehicles and conventional vehicles, we have different driving situations. So again, we calculated the emissions through the vehicle-specific power detailed methodology, and here we quantified emissions for for connected automated vehicles in different road types: urban roads, national roads, and motorways. So here you can see on your right some of the results. The first set of graphics for urban roads, then in the middle national roads, and at the end the motorway. And besides the baseline scenario, we considered other scenarios of penetration of automation, so 10, 20, 30%, 50%, up to 90%. And what we found out is that results suggest that the automation can significantly influence the environmental performance, either in a positive or negative way, depending on the driving settings. And we could conclude that the most negative impacts occur in the urban situations. So we can see that the total emissions of CO2 and NOx can be increased by around 4 to 8%. And the big advantages in terms of automation occur if we have automated vehicles on national roads and on motorways. For example, in motorways, and if we optimize the speed for around 90 kilometers per hour, we can have reductions up to 18% of CO2 and even 32% of NOx. So, as I said, this first was to separate the automation factor itself, and then we can now rely of joining the automation with the electric mobility, because we thought that this could be also an added advantage besides having only gasoline and diesel automated vehicles. So next slide, please. So here we applied automated driving in a national road type of route between the university and the science park, again, in simulation purposes. And what we can see is that if we have automated driving electric, we can save up to almost 50% on CO2, and also in terms of NOx, we can decrease the emissions of NOx by 56% if we have half of the fleet automated vehicles and electric vehicles. Let me point out that here we are considering the emissions that rely from the electricity production as well. So it's not only the local emissions, but also the emissions that are produced in the electricity production itself. Next slide, please. So we were about to say, okay, the electric mobility together with the automation have some advantages in terms of emissions. What about on air quality? So that was the next step, to understand the effect of automated and electric mobility on the concentrations. So here we calculated nitrogen oxides, also CO2 emissions, and we developed several scenarios related with the penetration of automated mobility and then electric automated mobility. And basically, with electric automated mobility, we found out that we could achieve emission reductions of about 30% when we talk about NOx and CO2. And when we looked at the air quality parameters, namely concentrations, we can obtain a reduction on NOx concentrations if we have automated and electric mobility. So the obtained results highlighted really the ability of having automated electric vehicles to improve the urban air quality. Next slide, please. So here, besides automation, electric mobility, let's go and have another layer called shared mobility. So this research aimed to study and evaluate the environmental aspects of the penetration of shared vehicles, electric vehicles, and automated vehicles. So here we made several scenarios, and basically with realistic combinations of alternative mobility penetration scenarios, we could have a range of -22% to +6% for CO2, and get about a range from -35% of reduction for NOx, but also an increase on a 5% of NOx. So here we could analyze in terms of this increase of emissions the critical sectors, and although increased shared mobility and electric mobility are generally positive, it is necessary to be aware that these new mobility forms can lead to potentially adverse emissions in some sections of the network. So, for instance, I can increase the capacity on highways, but basically, if I have a high penetration of electric vehicles, they can be more efficient at lower speeds. So, for example, on national roads. So, basically, I can join shared electric and automated mobility, and this joint adoption can pave the way for emissions mitigation and for a significant reduction on traffic congestion. Next slide, please. So this is the final piece of research. I don't know if the slide is appearing. Can you go into the next slide? And yeah, thank you very much for the input. So basically, if we go only from a use approach to a life cycle approach, so considering not only the use of the vehicle, but also a life cycle, the production, the use, the end of life, so all the steps when we look into a shared electric and automated vehicle, we can, using life cycle assessment, we can quantify all the impact. So that's what we made here in this work, and this is a research that involves a collaboration with the University of Coimbra, also in Portugal, and the TU Delft in the Netherlands. So if you go into the next slide to show some results, we applied this life cycle approach, so the entire set of processes involved in the shared electric and automated mobility, to two different vehicle seating capacities, so non-ride sharing, only one passenger, and 4 passengers, so a ride sharing scenarios. And we can say that the maximum vehicle capacity yielded a potential reduction of more than 41% on the system environmental impacts when compared with the single user trips. So a higher vehicle capacity in an intercity shared automated and electric vehicle mobility system has a significant reduction in the fleet deployment needs and a reduction in life cycle environmental impacts. If you go into the next slide, please. Also dealing with this, we looked into the role of electricity production. So you can see in green color, basically the highest impact categories that we can decrease. So if we compare the Portuguese electricity production mix with 100% photovoltaic and 100% wind power electricity production based, we can have and we can conclude that the electricity generation based on wind power is the most promising way to reduce the environmental impacts, with the potential to reduce up to 49%, depending on the impact, compared with the Portuguese electricity mix. So if you go to the next slide, I will enter in my final slides. So we can conclude, or until now with our research, we conclude that CCAM emission impacts, we have the concern with the transition period, so the coexistence between automated and conventional vehicles. If we have automated vehicle with electric vehicles, we have a higher potential to reduce emissions and to improve the air quality. And if we introduce these alternative propulsion modes, we have to have in mind that they are this is a promising strategy to reduce emissions, but does not imply a lower traffic congestion. So this integration with behavioral change techniques like shared mobility is a key factor. And if you go into my next slide, so because what is the mobility that we really want for our future? If you can go to the next slide, please. Yeah, because I can transform conventional vehicles into electric vehicles or autonomous vehicles, but I think that we really want an holistic integration of CCAM with public transport, active mobility, land use concepts such as the 15-minute city, because only with this intersection of approaches, both from the technology and behavioral side, we can achieve a true smart, inclusive, safe, and sustainable mobility. And if you go to my final slide, please, I finish here my presentation, and I would like to acknowledge the team of research on mobility, namely to my co-authors, and namely to my colleague Jorge Bandeira, that also presents and supervises a research on automated vehicles. Also to my funding agencies, and I thank you very much for your attention. I look forward to for the discussion.
Excellent. This was really insightful presentations. Thank you so much, Professor Coelho. I had actually one question for you, but I will skip it for a little bit later, because I think you created a perfect perfect bridge to our next speaker, Jos van Vlerken from the city of Copenhagen, who is also going to tell us a little bit how the city of Copenhagen sees the wider mobility in their city, and how also CCAM and automation and connectivity fit into their daily life today and tomorrow. Jos, the floor is yours.
Yes, thank you very much. I will be talking about the CCAM and how it fits with, as Zeljko said, how it fits with our very cyclist-heavy focus on regards to traffic, and I hope this kind of brings some inspiration and some new perspectives to the audience. Yes, next slide, please. So, how can ITS data and new technologies, of course, including CCAM, be used to improve and increase cycling in cities? That's the basic question that I'd like to pose. Next slide, please. We in the city of Copenhagen have some pretty ambitious plans. We want to be climate neutral by 2025, so in already 4 years. We have a bicyclist strategy which proposes to increase share of trips on bike to 50% by 2025 we are already at 42% by last year. This was not due to COVID, as you might expect, because it was actually there was a decrease by 2 percentage points since 2019. So we're pretty close to reaching our modal shift goal, so to say. And we're starting to focus heavily on making bicycling the main mode of transportation for the medium range trips. They are already being carried out by cycling, but also the long range trips, so 15 to 30 kilometers. I just wanted to have this slide to give you some context of what Copenhagen looks like and what our policies look like as well. So next slide, please. Yes, and the thing is, let's say the challenge that we have is that there is an abundance of technologies. CCAM is starting to get there now, but already CITS and ITS solutions already exist for cars and motorized vehicles, but to a significantly less degree for cyclists, and that is something I'd like to make people aware of, because we already foresee. We already view we already have the green mode of transport of the future, which is the bicycle. So shouldn't we try to promote some technologies that kind of take that into account in a way? Next slide, please. So what can CCAM do for cyclists, basically, right? And I for the next few slides, I want to introduce you to what we are doing with this ITS and CITS, and as I said, give you a perspective of cyclists on CCAM. Next slide, please. Yes. So what we're doing at the moment, we have a multimodal traffic management system. Of course, we're sharing this system with many Dutch cities and provinces, and even their Rijkswaterstaat, their National Road Authority. It has a lot of modules that take account of cyclists in daily traffic management. We can do a scenario management. We can do integrate cyclist data. So that's quite interesting. That's one of the ways we try to kind of view cycling as a mode of transport on the same level, or even a higher priority than cars. Next slide, please. We're trying to get as much data as possible, so counting data, travel time data, that kind of stuff. We have some experiences from technologies which are pretty good for cars, so loops, coils, radars, all that, which don't work on cyclists. They are basically too small, and when they're grouped together, cyclists, it skews the data. So we're looking into camera and automatic image recognition. Here I want to pose another question: is how can connected and automated vehicles help detect cyclists, share that data with traffic management or road authorities? What technologies can we kind of get from automated vehicles? Maybe LiDAR is an option, or something like that. Some of the progress made on, of course, automatic image processing, that's also related to automated vehicles, of course. So that's very interesting for other modes as well. And also can these vehicles also detect cyclists to a good enough degree? Next slide, please. Scenario management, as I said, we are adjusting our traffic signals, our whole infrastructure to a larger and larger degree to accommodate the slower speeds of cyclists, to accommodate different the variations in amounts of cyclists that we have. So that is one other thing. We foresee the city becoming more and more adjusted to cyclist traffic rather than motorized traffic, which I'll come back to that in a minute. Next slide, please. We've just finalized development of a traffic model. It's a mesoscopic traffic model. It's a multimodal traffic model, which is one of the hardest phrases to say. It models multimodal trips, so trips that start off as pedestrian trips, then they become car trips or cyclist trips or public transport, and then they end as pedestrian trips again, for example. So it models the whole trip regardless of which mode is used. There is, at the moment, this model does not take into account, even though it's pretty cutting edge, it does not yet take into account automated vehicles. And this is one very interesting avenue of further development, is to look into into the future, how can we model traffic with automated vehicles, and this is one of the previous presentation was very interesting at that point. Next slide, please. So yes, the question is, one is very interesting thing that we're doing is we're trying to further increase, of course, convenience of cyclists, and for that we want to reduce the number of stops. Next slide, please. And we're trying to do this within the C-Mobile project. You can see some stats here. I'll go pretty quickly through it because I think I'm on schedule. Next slide, please. So we're trying to achieve increase in convenience for cyclists, of course, also the other modes, but it's primarily focused on cyclists via this the Green Catch app developed in the C-Mobile project. And next slide, please. Its primary function is to give GLOSA advice, so to take account of the modes of the traffic signals and the traffic signal state and the speed of the vehicle, to be able to give an advice on the speed that the cyclist can take, so that the cyclist achieves a better flow going through the city with this without having to stop at intersections. Next slide. So we are building solutions and services to improve cycling convenience and to promote the modal shift from cars to bicycling. But as I mentioned, there will always be cars and trucks, emergency vehicles. There will always be a need for motorized vehicles, basically to transport people. Whether it's in the future, the share of which will, to a larger degree, be the automated vehicles. But what I want to have people kind of contemplate is how can these vehicles improve the conditions for cyclists as well, further than not only just by the, let's say, maybe the space, public space reduction, but also in their functioning in themselves, in the data they provide or gather, in the way they detect, also for traffic safety reasons. Do they ignore cyclists when driving forward? Of course they will not, but what are the settings, to the safety settings? How will they manage a city that is very heavily a cyclist city? Will they be at a standstill because maybe they see dangers all around them? This is an interesting question that I'd like to kind of explore going into the future. Next slide, please. That was all from my side. Apologies for the noise in the background. I hope you could hear me anyway. Thank you very much.
No, we could hear excellent in an excellent way. Thank you very much, Jos. Really interesting now to hear about a more holistic approach to the city mobility, how one of the cities in Europe is thinking about this. And I also have, again, the questions for you as well, but I think this is perfect time to go over to Pierre from NAVYA, because I think you posed a fantastic question. What is going to happen with, for example, self-driving shuttles when you have 10 cyclists around them? Are they going to be constantly at a standstill? But before we get into that debate, let's hear about Pierre and his work and the fantastic work that NAVYA is doing on vehicle automation. Pierre, the floor is yours.
Thank you, Zeljko. Hello, everyone. Well, sorry for the, I did not put the title of the slides. So we can start by showing just a small video, and it will allow you to see why we can, from NAVYA side point of view, we can talk about this topic. Please, next, the video. Usually there's a little bit of music here, but nevertheless. So you can see our shuttles driving around across the world in different situations, in different cities, in different conditions for different passengers. So here we are in an airport. Here we are in touristic sites in Singapore. Here we are in a hospital. We are around stadiums. This is in Lyon. And here just our technology was awarded by the Dubai World Challenge, where we proved that the technology is there. And also to show that the AV is not only for shuttles that you are doing, but can be adapted also to industrial situation where we can move the vehicles in industrial sites in with the autonomous driving system and have the people to work to move to other competencies. One of our latest experimentation is that we have the shuttle without operator on board, what we call no-op. Okay, thank you for this video. So you can see, well, I've took just one word from the sustainable and smart mobility strategy that Europe highlighted in December. The success of European Green Deal depends on our ability to make the transport system as a whole sustainable and resilient. And we can see that electrified autonomous shuttles, level 4, as was highlighted in the beginning of this session, can be cleaner, safer, sustainable, and more efficient and inclusive. So from next slide, please. So NAVYA is working on this since 2015. Next slide, please, if we can. Great. So we can see that the challenge is great, and we can talk about this from a NAVYA point of view because we have all our vehicles running from Florida to Japan. We have now, while speaking, we have 80 shuttle driving across the world from Florida to Japan. And this is in different situation in level 4, what we call SAE level 4. In different use cases, answering different kind of challenges, needs raised by the cities. So we can talk here about shared and public transport. In what we call level 4, it's a confined area, whether it is a private site or whether it is on open road in urban use cases. And we address different kind of citizens, of passengers, from elderly to youth and to patients in hospitals, etc. So we've taken into account different needs when the PTAs or the city come to us. We discuss them together and we check if the challenge can be raised, and we put our vehicle there only if the challenge can be raised. So we will discuss this use case further. You can see here we have cities, airports, etc. We already highlighted. But if we go to the next slide, please. So here we can see what is the request from the city point of view regarding putting in place shuttle. Why do they want to put in place shuttles? So we can see in cities, most of the time it's to enhance and to extend the public transport and to connect one point to another. We see also it's to follow and to respect the ecological transition. Many are here to prepare the future, to test this new solution and to see how it could be implemented in a urban design. And also we can see some of them, it's only for the image. And when it's only for the image, it's not sustainable. We know that. But we can see that sometimes this image triggers and then it goes back to respect the ecological transition and to extend it to other use cases. In industrial and business park, it's used for internal transport. Some of the sites are very big, and to move from one building to another, they take their cars or they move on walking. And we see some industrial sites, they are putting electric cars or other. But here, some of them are using our shuttles. So to do so, we are putting several shuttles and we manage the efficiency. And how we manage it with on demand. So if there's no need, the shuttle is on stop. And where there's a need, we adjust this demand. We manage it also in dynamic planning. And dynamic planning means that, well, in the morning, the shuttles are mainly focused on the parking, to move people from the parking to the building. And when it comes to noon, so people want to go to the cafeteria to eat. So it will be more focused to moving people from the buildings to the cafeteria. And between these two, the shuttles will be parked and there will be only on demand. And that's also the reduce of the use of the car in the business park and industrial sites. And also innovation. Many industrial sites want to move this ecological footprint, and they want to put innovation in place. In campus, it's also for internal transport. It's to connect the public transport, the mass transport, to the campus. So it is used also for this economic transition and innovation. We can see that it's widely used in campus where the technological part of the education and the diplomas in the center are more often. And in touristic sites, we see it more and more, as you've seen in the video. It's to put innovation in place. And here it's the perfect choice because it's electric, it's automated, so it's innovation, and it's for tourists, so they can enjoy the ride and can benefit from these innovations. And then in airport, it's the same. It's innovation and ecological transition to reduce the footprints. But now in hospitals, we can see that it's adapted to the patients and is adapted to the use. It does not go at 50 kilometers per hour. It's adapted with a ramp, PMR ramp, for elderly, for wheelchairs, and it is used on demand and adjusted with dynamic planning. So this is used by the patients and it is used by the people in the hospital and the personnel of the hospital. So the comfort of the shuttle is used a lot of time within different situations. Next slide, please. So I give you some examples. This is one example of an experimentation that we did in Lyon, and why they wanted to put this in place, and what is the impact on the decarbonization. So you have, on the left, you have a tramway. It's the end of the tramway here, and around you can see there are a big business park. So here we have something around 2,000 employees that is coming each day, and only 10 to 15% are using public transport. So we wanted to experiment the percentage of people that will use a new solution that we put in place. And so the idea of putting shuttles here is to take the people from the tramway to go to their sites, to the business park. And it's only 2.5 kilometers. So sometimes for just some kilometers, people will take their car for their daily trip in the morning and in the evening. So we put in place these kinds of solution, flexible, on demand, electric, and can deliver the service. So we push people to reduce their costs. And we have seen this percentage going a little bit higher. I don't have the exact figures here, but we have seen that at least it was up to 20%, and it allowed people to say, yeah, when I come to the train, if it's raining, if it's hot, I can take these solutions, and it allows me to go there. And these solutions are always there. So we are adapting, we are doing dynamic planning to adapt the shuttles to be on time for when the tram arrives and to take the people around. So this is one of the example, and I call it a water leak here, because if you have a pipe, which is pipe of water, here it's the mobility, and you have just one hole of 2.5 kilometers, well, you will use another solution to work around. So here, with this, what we call first mile, last mile, we see it often. This is to block this leak of water. And most of our use cases are there. If you go
Pierre, this is really interesting. Can I just please ask you to round up in 2 minutes, please?
Okay.
Thank you.
I'll go quickly. So next slide, please. Here is another solution. It's another experimentation we have in rural area. We are trying to put in place for 20 kilometers, connecting several villages. And here it's a real example for decarbonization. I call it externality. So in these villages, we have elderly people. It's a low density and investment in public infrastructures are separated in the different villages. So you have a medical center in one place, a school in another, a sports center in the third, etc. And they need to connect these people. And we are putting these on-demand solution to go there to connect these people. And why a normal solution cannot be there? Because you are moving 5 to 10 people per day. So if you don't have a viable economical solution that can be on demand, it will be very, very difficult. And decarbonization here is not on the vehicle itself, but it's more that we cannot build all these infrastructures in all the different communities. So it's an external decarbonization solution where the autonomous shared vehicle can do an effect here. If you go to the next slide, please. Here we have another solution in the hospital where the our shuttles are the perfect match. We don't go fast, it's comfortable, and it's on demand. So we are in a hospital area, and we mapped all this area. It's a 9.2 kilometer of roads that we connect them all together. You have 3 shuttles running every day, and it is on demand to take you from one point to another. So decarbonization here is related to reduce the people to use their car internally, to help people to move around. And also, usually here there are 2 big buses that are running, and these 2 big buses are destroying a little bit the road and the infrastructure. And these on-demand shuttles are flexible and handy, and they can be only used when it's on demand. And they are small, they are parked on the side. It's not like the big bus, they do come from the outside. And it brings the perfect solution to this hospital, where there's a lot of internal and external people there. The last solution, the last slide, please. So we are moving, as you have seen, I talked about experimentation, but for us, it's more deployment. And here, it's a right example going from experimentation to commercialization. And in one big city, a city of 1,500,000 of employees, they want to extend the public transport. And we put in place a new commercial dedicated line called L490, where 3 vehicles are running 5 days a week, 12.30 hours a day, each day, and they are going around with a frequency of 8 minutes. And they are connecting all these people to go to work in the morning. So this is also the water leak then we can breach here, that we can fill, to provide a new solution to push people to use more public transport. So you can see shuttles, level 4 shuttles, are bringing a solution to, or an alternative to have people use public transport and to push them to leave their cars away. Thank you.
Excellent. Thank you so much, Pierre. This was really interesting because we also got insights from the real life operations and from, as you rightfully said, not only experimentations, but also deployments. And that basically we are already ready in some specific cases to implement vehicle automation to support the real life needs. Excellent examples. Thank you so much, Pierre. Now, this was focusing a little bit more on the passenger transport. And as a final speaker, before we go on to the interesting discussions, I would like to welcome Richard Bishop, who is going to tell us a little bit more about what is happening on the freight side, especially in the US, but maybe reflect also on other regions as well. Richard, the floor is yours.
Okay, thank you very much, Zeljko. I'm happy to be with you all today. Right, hopefully my slide will come up. There it is. Yes, my job here is to talk about goods movement, the key factors of driving connectivity and automation in goods movement. If we go to the next slide, please. What I'll be talking about is 4 sectors out there. The idea of controlled environments, streets, resource roads, and highway. Next slide, we'll talk about the street side. Of course, these are very familiar applications. On the street, it's a complex environment, low speed. It's a customer-facing focus. It's a very strong market, as we know, based on the pandemic and other factors, but also very challenging. Nevertheless, there's a lot going on there. Next slide, you can see 3 examples that I have. Waymo is well known for their robotaxi activities, but they've also created another brand called NAVYA that's specifically about goods movement. They're working with UPS and others. Jeftic is very interesting. They're not doing the full highway operations. They're doing B2B between a Walmart distribution center, for instance, and the retail store. Repeatable routes, which makes a simpler environment and allows them to come to market sooner. So you see my point here. They're deploying fully driverless goods movement on streets in this year. And of course, Einride is there, which is very well known. They have been doing things in Europe and will be moving into other parts of the world. If we go to the next slide, in terms of the business to consumer, Neuro is the one, at least in the US, that has the most going on. And they also have said that they are introducing driverless deliveries starting in Houston now. So let's continue. Next slide. There's the other area called controlled environments, logistics yards, etc. They can be low speed, very dirty, dusty, specialized, high user need, and kind of a small market. And yet these are excellent settings to introduce automation. And Pierre from NAVYA showed a couple of examples. Next slide. My example is a company called Outrider. that is working in the yard, as we call it in the US, the classic distribution center with a lot of loading docks. Trucks come in off the road and they're maybe dropping their trailers at a storage yard, and the trailers have to be shuttled around a lot. This is done by people now, but it's ripe for automation, and it's ripe for electrification as well. So there's a lot happening in this space, and Outrider is a good example. Let's go to the next chart. Resource roads is not talked about as much, but you can see from this photo that there are truck operations that happen in remote areas, unpaved roads in some cases, very important industrially. Let's go to the next chart. You'll see this logging truck, Forest Product Innovations, is based in Canada. That industry, just in moving timber from the cutting area to the mill, has a huge driver shortage, as is true for trucking in general. They're very interested in automated follower platooning that would allow one driver to carry, to control two trucks, in essence, with a driverless follower. They're launching this project this year to adapt commercial systems to these type of rural public roads. Let's go to the next chart, and this is the highway world. This clearly is where all the money is, where the focus is for the majority of the players. It's a well-ordered environment. It's very high speed, so the risk is high, the kinetic energy is high, yet it's a huge market, and that's what's driving things. There's two operational modes, platooning and solo driverless, and I'll talk about each of these in turn. Let's go to the next slide. Just to sort of review what truck platooning is, it's about two trucks closely drafting each other, a very small gap between the two trucks, done safely. Truckers in the US, at least, will try to do this, and it's unsafe in case the front truck brakes suddenly. This is a way of doing it safely, and when you do that, you can reduce your fuel use. Several tests have shown in the real world about a 4% fuel economy benefit for the leader truck and 10% for the follower truck at conditions such as 60 feet gap and 60 miles an hour. In practice, the gaps will be less than 60 feet. These fuel economy benefits scale with speed, so that's interesting to compare the US market with Europe, where the speeds are much lower in Europe, special truck speed limits, whereas in the US generally the trucks run at the same level of speed as the cars, so much higher speeds on average in the US, which translate in platooning to much greater fuel savings, and of course fuel savings translate to reduced emissions. The whole idea here is close following via connected braking between trucks using low latency vehicle-to-vehicle communications, and it is focused on the highways because of those higher speeds. Let's go to the next chart. There's two generations of platooning that are both being developed for the market. Level 1 platooning, first generation, front driver drives normally and the rear driver is very much in the game, steering and monitoring the road and responding to traffic. It's just that the foot pedals are automated. And then the second generation is called level 4 following, where the front driver is driving normally and there's no driver in the follower truck. So in the first generation, you get a fuel economy benefit. The second generation, you get fuel economy plus a labor savings. Let's go to the next slide. These are the major players that are out there. You see on the bottom, I've noted several of the truck OEMs with an asterisk. Most of them haven't been active publicly lately, but they certainly have the capability. Going to the next slide. Typically in the US, there are hub-to-hub operations where trucks are dispatched pretty much together in time. And so the early platooning in the US, at least, will work with these companies that are doing hub-to-hub. And that way there are trucks that are platoon equipped leaving the depot at the same time, and it's a very good fit with platooning. Let's go to the next chart. Here we get into the highway solo driverless, as I call it, individual trucks that are automated. You see all these logos and you see the OEMs below. There's a lot of activity, a lot of money in this place. Most of you may have noticed that Too Simple just recently went public on the NASDAQ stock exchange. Let's go to the next slide. Just a few key points. In terms of development and testing, there are no driverless trucks on the road now. There are trucks that are level 4 intent, meaning they're designed to be driverless, but now they're being evaluated on public roads, backed up by safety drivers. A couple of notes on the individual players. Kodiak just announced they've done 800 miles of continuous disengagement by that safety driver and runs in Texas. Too Simple has said they're going to be doing their first driver out runs in late 2021. Plus is working for independent validation with a well-known transportation research center in Ohio. And of course, the OEMs, Daimler and Volvo, have large internal operations on automation, and Daimler has partnered with Waymo in particular. Let's go to the next slide. On the efficiency side, fuel efficiency, most of the developers are seeing fuel savings from solo automated driving. There's not the dynamic of platooning, but what they do have is essentially the best driver possible operating that vehicle. You get away from that driver variability. In terms of deployment, I'll just sort of skip a couple of these bullets, but Plus is interesting. They are putting product on the market this year, starting in China, of what they call a supervised level 4 product, meaning a system developed for driverless, but being supervised by a commercial driver. They have deliveries underway and 10,000 pre-orders to do this. So we'll see this supervised level 4 coming soon. Next slide. In terms of sustainability, an interesting example is the company Land O'Lakes, which does dairy and mainly butter, partnered with Plus to do a hub-to-hub trip from California to Pennsylvania, 2,800 miles, in less than 3 days. That's because without any driver hours of driving limitations, they can do that. And when you think about the sustainable goods transport of simply a refrigeration unit on that truck, whether it's running frozen goods or butter or whatever, running maybe 70 hours instead of 150 hours for that trip. Let's go to the next slide. These are just some slides showing sort of that timing summarized. The control environment's coming quite soon. As I said, we'll see the street operations this year from Gatic and Neuro. Resource roads will take a while. On next slide, and then we'll see the majority of the deployment of solo driverless around 2024 when the OEMs are ready with factory prep trucks. Just a couple of points, and I'll wrap up. What are the sustainability factors for a truck, long-haul trucking? Truck platooning clearly provides substantial benefits. As I mentioned, the solo driverless trucks have the optimal drivers for fuel economy. Plus, the solo driverless truck hauls can shift to overnight hours, which in some corridors can really reduce congestion for other vehicles during the day. And my last point is to say that AV and EV are very different things. They tend to be mashed together in some discussions, but the AV market is driven by the driver shortage and economics. The EV market is driven by sustainability, ease of maintenance, and other factors. We'll probably see over time goods movement will evolve to both AV and EV at different pacing, depending on the nature of the load and the trip. And I think the EV will scale up much quicker. Next chart, and that's my conclusion. Thank you.
Excellent. Many thanks, Richard. Really interesting to also hear what's happening in the US market on the freight side. Now, we are going to go and ask you a couple of questions. You need to suffer a little bit for being with us in the afternoon here. So, Richard, I'm going to just jump to you immediately. You've just woken up a couple of hours ago in the US. You may even not have seen the news, but apparently the Biden administration is going for 50 to 52% of carbon greenhouse gas emission reduction by 2030. Fantastic news for all of us tree huggers. But at the same time, this is also greatest probably business opportunity for the transport sector. Do you believe, without knowing the details, of course, of what this will actually mean from the Biden administration on transport, that actually this could be a good push and business opportunity to speed up the vehicle connectivity, the vehicle automation, and uptake of all the other ITS solutions?
Yeah, I think it could. From what I can see, the majority of focus will be, when it comes to vehicles, will be on electric vehicles and charging infrastructure and that type of thing. But when you have hundreds of millions or billions going out by the government, you can always take 1%, and it's a lot of money. And I think that type of number will be available to connected automated vehicles.
Excellent, excellent. Many thanks. Now we're going to go into question time, and I just want to ask all everybody in the audience. We have just launched a question on Slido. If it's about your perception if CCAM connectivity and/or automation is going to be able to have an impact on the environment that we are discussing today, basically. So going back to Professor Coelho, I just want to ask you, you are one of the few people that has done research on CCAM and the environment. What do you foresee? What are the next needs? Where should we research more? What needs to be done more on the research side to understand the benefits? You need to unmute yourself, sorry.
Of course, I had to screw something in these technology platforms. So yes, thank you very much for your question. Actually, the results that I presented are very fresh results, so we are still ongoing. We are still developing some ongoing research on that. So basically, we have several challenges in order to address these environmental effects of automation. And for example, the access of real data to a real data is crucial. Not only data from automotive industry, but also the smart mobility platforms. So how to get these open real data in order to calibrate and validate properly the modeling platforms. And in terms of research needs, maybe the integration of modeling platforms, how can we address properly the impacts of automation together with the other road users, namely bicycles, pedestrians, e-scooters. This is a really research need to understand all the ecosystem of mobility. Then another main challenge that, for example, for me, we have this challenge every day is to integrate data from different equipments and different modeling platforms, and also the big data that comes from, for example, from automation. We have terabytes of data. How can we turn this into useful data? Not only for researchers, but also for policymakers. How can this big data can be really useful? And I think the essential point, and I listened to the keynote presentation on EUCAD Wednesday morning, in which we know that the Horizon Europe guidelines is aligned with the guidelines for CCAM, also for the European Union Sustainable and Smart Mobility Strategy. And we have to involve researchers from different fields and also other players. So I think in terms of needs for the future, we need to join different skills, different expertise, automotive industry, ICT companies, operators, working together with researchers, because from the intersection of this knowledge and these skills comes the innovation.
Thank you very much. A short follow-up question to you, but also to all of the other speakers that we had. There's a question here from the audience. Are you aware of the studies that analyze the energy consumption and its environmental impact on connected and automated vehicles due to processing of data? Are we aware of any studies on that side, or is this yet another topic that we need to add to our research agenda?
Thank you very much to whom made the question. Actually, I didn't have the time for the details, but on this life cycle assessments approach, we are taking into account the energy use related with the data processing, and also the sensors, the materials related with the sensors that have to be installed on the vehicles. So this is very important from a life cycle approach point of view to address also what was mentioned. Yes.
Excellent. Richard, yes?
Yeah, it is true that there is more power consumed by the processing and the sensors, et cetera. And I'm not an expert on this, but I think compared to the power needed to move heavy vehicles and people and goods, it's a very minor increment in power consumption.
Thank you very much, Richard. Yes,
Allow me to
Pierre.
add just one point also. To complement this question, some will say also we need 5G, and 5G will consume a lot, and using the data will be very huge. But you have to take into account that these kind of technologies, the vehicle is autonomous, and he will drive autonomously. And 5G will be here to guide. We will not use 5G to send all the data, to have a huge farm, servers everywhere, to analyze all the data. No, the vehicle should be autonomous, and the 5G is here to support and to guide as a tool, and not to treat, interpret, and use a lot of energy to use these data.
Very interesting. So autonomous vehicles means also very much intelligent vehicles themselves, not only, let's say, sensors on the wheels that are steered by the control center, so to say, for every single decision. Thank you very much, Pierre. If I just can follow up with another question. So you have implemented now 80 vehicles in different locations. What are some of the biggest difficulties for you when you're trying to implement these vehicles in real life operations in hospitals or other locations that you are implementing them?
Well, thank you for the question. The difficulties, well, there's one main we can see is the expectation. Most of the cities, the clients, when we started, they were seeing autonomous vehicle as, okay, you have a vehicle, you push a button, and it will go around. It will solve all different situations, and it will overcross stopped, parked vehicles, etc. And they will have zero problem. But nevertheless, this is a science fiction, and the expectation is something that we are facing as a main challenge. When we go and we check with the city, the PTO, to see what we need to put in place, we bring them back from the marketing they have seen on the internet, on the media, to the real life, and telling them, well, we can put it in place, no problem, but we need to do this and this and this. And we need to solve like these small situations, and then we will need to put operation people around to solve if there's any issue. And here we go into this operational part. I give you one example. I give you two examples. One of them is we talked a lot about one of our experience in La Défense area. It was an experience for 2 years. And in La Défense, you have, well, like 500,000 people coming around, and it's a walking area. And at the end, when we finished, we had a lot of problems because people are walking all around the vehicles, and the vehicle is stopping because the people are there. And at the end, we have received a kind of, at the beginning it was a positive feedback, but at the end we received a negative feedback, like saying it's not going fast. But the idea here is not to go fast. The idea here is to move people and to bring a solution. A second, it's a kind of joke. Well, one of our clients a couple years ago wanted to have a shuttle, and he said, okay, I'll buy a shuttle. How much it costs? Okay, how much it costs? We gave them the rate. And then he said, okay, now where is the button to push it, to put it in place? I need people behind it too? Oh no, I thought it will go around. I don't need to have operational people there. So the expectation, the level of expectation is very important to bring it from the science fiction, from the media we are seeing, to real life.
Thank you very much, Pierre. Indeed, expectations is very important to get it aligned between the different stakeholders. Now, talking about expectations, but also talking about user acceptance, we have seen studies that indicate that people are sometimes a little bit hesitant towards vehicle automation. And if anybody in Europe is good at supporting citizens with to change their behavior or encourage them to change their behavior, it's cities like City of Copenhagen. So Jos, I would just like to ask you, you have managed to support your citizens to change their behavior to be one of the champions on cycling in Europe. Can we learn anything from the process of how you have actually engaged your citizens on the cycling, so that we can also engage with them and get them to adopt also this, or to be more positive towards vehicle automation as a part of broader mobility and public transport?
Yes, I think, well, there is one essential thing to do is to make it as convenient as possible, right? In Copenhagen, we believe, of course, that a motivation to start cycling could be something like the environment or health benefits. That let's say that initial motivation lasts approximately, let's say, 2 weeks or something, and then if you want to kind of keep people cycling, it needs to be the most convenient mode, right? So increasing convenience, as I also mentioned in my presentation, is the key to achieving this. As we roll out automated vehicles or automated public transport, for example, it's important to note that what we do not want to achieve is to have a modal shift from cycling to these automated modes of transport, right? Cycling has so many benefits, health benefits, even though people don't, even though the individual's motivation to cycle, for example, for health benefits, stops at some point, the societal and socio-economic benefits of cycling are immense, especially because of public health, the public health effect, right? So we do not want our existing cyclists or our future existing cyclists to shift to these modes. But what we do want to see is the private car ownership to decrease, and if automated vehicles or automated public transport can help us achieve that, that's a positive. And then we will structure, hypothetically, we would then structure, well, the traffic planning in the city to kind of accommodate that. That is, allow these modes to pass places where private cars, or let's say, private cars cannot, for example. As such, we primarily see the benefit of automated vehicles when it comes to something like kind of a public transport or public transport shared vehicle type of transport, right? So what we want to achieve is not promote necessarily more private cars that are automated, but promoting a shared transport type of situation, right? And convenience is key. So of course you can do all kinds of communications operations and whatnot, but if the practical task of moving about the city with a automated vehicle, or any vehicle for that matter, is inconvenient, then the behavior of the people will not kind of follow.
Thank you very much, Jos. Very interesting insights from all of you. I just want to reflect before we start wrapping up here. We have 6 minutes left. I just want to reflect on a couple of comments from our audience. We have one of our colleagues mentioning that we should also not look only at full automation, but we should not forget the ITS that is already mature and that could provide the benefits. And that is absolutely right. We need to use all of the technology, services, policies, basically to get reduction of the greenhouse gas emissions from the transport. And this is going to be just, I believe we are just starting basically to work in this field. There's going to be much more. And then we're also talking here about less idling of the different vehicles. Absolutely. There are many side benefits that we see from the vehicle automation. Now, I will take the last 5 minutes to wrap up discussions. And I would also like to encourage last one of you to also use the last minute now to cast your vote in Slido. And then we are going to see the results. But basically, what we have discussed today is that the climate change is here. We need to decarbonize, and all across the world, we now see the strong movements. My personal belief is that we are going to see changes in these coming 9 years that are bigger on the transport and mobility side, that are bigger than what we've experienced in the past 60, 70 years. Now, maybe that is true, maybe not, but this is a great business and societal opportunity for all of us, basically. We have seen that from the research side, that there are benefits from the vehicle automation, vehicle electrification as well. We have also seen that there are benefits from the shared mobility as well. But we also need to be a little bit self-critical when we are thinking about shared rides, as an example. Are they going to explode or be boosted up now through automation? Why? Shared mobility, for example, is not down to if it's automated driver or if you have a driver in the driving seat. These are many of the topics that need to be further researched, and we should not blindly believe that the new technology is going to solve all of our issues, which sometimes are coming down very much to our behavior. Still, we have heard very many examples today from the city of Copenhagen, how we can use connectivity above all to make the cycling more friendly. How can we coexist also with future autonomous vehicles as a part of the public transport? We have also heard from NAVYA about many of their operations in the different parts of the world, where the benefits are not only actually on the vehicle side, but there are societal benefits that are still supporting decarbonization. Having a couple of villages being able to share a common library so that you don't actually need to build a new library in every city, but now you can actually afford having a self-driving shuttle supporting the elderly and other people in these villages to come to each other and use the common resources. We also heard from Richard about a lot of different developments, very often driven by the business side and by the cost reduction and by the driver shortage, of course, as well. In the US, when it comes to freight movements, now some of these examples also have clear environmental benefits. For example, truck platooning, etc. So there's a lot of elements. There's a lot of promising. There's a lot of promising tools that we do have at our hands, and we need to move forward very quickly now with more implementations. I would typically say we need more pilots, but I'm not even sure if we have enough time for the amount of pilots that we need to have in order to achieve, for example, up to 55% reduction of CO2 emissions in Europe. So with that said, I would just like to thank the panelists who were very kind to be with us. And I would just like to ask each of you from the panel to just say one short sentence of what we should really focus in the coming 9 years. Not even a sentence, just a small statement. Professor Coelho, what is the key word to focus in the coming 9 years?
Yeah, I think the integration between technology and human behavior is key, and making connected multimodal automated mobility a reality.
Thank you.
A question, sorry.
Thank you. Excellent. One word, Jos, please.
Decarbonization in general.
Yeah.
Thank you very much. Pierre.
Well, for me, it's developing public transport to reduce personal car usage.
Excellent. And Richard, very briefly, one word from your side.
Intelligent, thoughtful development of regulations.
Thank you. Can we please see the results of the slide very quickly? And then we are all going to go into the final panel discussions. We see that you all think that benefit of CCAM on automation is going to very much be dependent on case by case. That is the winning one. Thank you very much to all of the panelists. Thank you very much to everybody in the audience. This is an exciting topic, and I'm sure we are going to be debating this and discussing this much more in the future. Please now close this window, go over to the agenda and launch the final session where we are going to wrap up all of these 3 days of this fantastic event. Thank you very much and have a nice afternoon.